Hello students. So today we will be learning about different techniques of integration. Okay. So we'll start with first technique, which is substitution. Okay. Solving integration by substitution. Now first rule, if you have a derivative in the numerator and the function is in the denominator, then you directly write this answer as log of mod of f of x plus c. Okay, this you can directly use formula if you know the derivative of the function which is in the denominator. Now second is when you have a trigonometric function sine and there is one more function inside it, then you can write this as integration of sine, which is minus cos, and the derivative will come in the denominator of this function, that is ax plus b, which is a. Okay. So let's see some standard results which we derive by using the method of substitution. Okay. So first one is you have to prove integral of tan of x dx is minus log mod cos of x plus c, or this is also written as log of mod of sec of x plus c. Okay, so let's derive this. So integral of tan, so using the trigonometric identities or trigonometric ratios. Okay, so tan of x is what? Tan of x we can write it as sine upon cos. Okay, so if I take this cos, means I am using substitution now. So cos of x I am taking as t. Now take the derivative, which is dt. Derivative of cos is minus sine x dx. Okay, now you have to substitute this over here. Now what will be this? Integral cos of x, you have taken t, okay, and sin x dx is your dt, so with a negative sign, so here it will be minus dt. Now minus you can take outside, so this will be 1 upon t dt. Okay, and we know that 1 upon integral of 1 upon t or 1 upon x is log of x, right? So minus log t plus c. Now whatever we have taken t, we have to write here, that is t is cos. Now we know that whenever we write using log properties, that is log of a raised to b, we write it as b log a, right? So this minus you can take as a reciprocal of this. So what will be the value? So this will be log, this will be what? Cos of x raised to minus 1. Okay, and cos of x raised to minus 1 means what? 1 upon cos, right? What is 1 upon cos? 1 upon cos is sec of x. Okay, So you can write this as log sec of x plus c. Okay, this is 1 upon cos, which is sec of x. Okay, so we got the standard result for tan of x. This you can add to your formula list. Okay, that is integral of tan of x is log of sec of x or minus log of cos of x. Okay, this you can write directly whenever there is an integration problem. Now another way to write this answer directly is using f dash of x upon f of x dx formula, which says that log of mod of f of x. Okay, so we know that sin x and cos x, derivative of cos x is sin x, right? And we have to add negative sign, so we can directly write this as log, which is cos of x plus c. You can use this formula or you can use the substitute in t. Okay, that way also. Now let's see the second one, that is cot of x dx, which is integral. This answer will be log of mod of sin x plus c. Okay, this I will solve by using f dash of x upon f of x. So cot of x, we can write it as cos of x upon sin of x, right? So sin is your function and the derivative of sin is cos of x, so you can directly write this as in this form. Okay, or you can use the t method, okay, which is substitution. Let's solve this integral sec of x. Okay, we have to prove it, log of mod of sec of x plus tan of x plus c. Okay, let's start. Sec of x, okay, you can write this as sec of x into sec of x plus tan of x upon sec of x plus tan of x dx. Okay, so we are multiplying and multiplying numerator and denominator by sec of x plus tan of x. Now take this sec of x inside, so it will be integral sec square x plus sec of x into tan of x upon sec of x plus tan of x dx. Okay, now if you look at this closely, we'll get that if I take the derivative of this denominator, okay, I will write here, if t is your sec of x plus tan of x, what is the derivative? Derivative of sec of x is sec of x into tan of x, right? And derivative of tan of x is sec square x, which is our denominator, which is our numerator. Okay, so we can directly write here using that method, that is integration f dash of x upon f of x. So this will be directly log of denominator, which is sec of x plus tan of x plus c. Okay, now we'll solve the next one, which is integral cosec of x dx equal to log of mod of cosec of x minus cot of x plus c. Okay, let's solve. Same way you have to do this, that is cosec of x, you have to multiply by this, that is cosec of x minus cot of x upon cosec of x minus cot of x dx. Okay, so we are multiplying numerator and denominator by cosec of x minus cot of x. Now take this cosec of x inside, so this will be cosec square x minus cosec of x into cot of x upon cosec of x minus cot of x. Okay. So if I take t as cosec of x minus cot of x, then dt will be a derivative of cosec of x is cosec of x minus cosec of x into cot of x. Okay, and derivative of cot of x is minus cosec square x. Okay, dx. So this sign will be minus minus plus. So we get the numerator here. So you can directly write this as log of mod of cosec of x minus cot of x plus c. Okay. Now there is one more formula for cosec of x dx, that is log of mod of tan of x by 2 plus c. Okay, let's see how to solve this. So cosec of x, you can write it as 1 upon sin x dx, right? Now this sin x, you can write it as using half angle formula 2 times sin x by 2 into cos x by 2. Okay, how you got this? Sin 2x is 2 sin x into cos x, right? So when you take the half angle, this will be x by 2. Okay, so we are using this formula here. Now you have to divide numerator and denominator by cos square x by 2. Okay, so I am dividing this numerator and denominator by cos square x by 2. So this will be cos square x by 2. Okay, dividing means I am multiplying a numerator and denominator by cos square x by 2. So this will be 2 times sin x by 2 into cos x by 2 into cos square x by 2 dx. Okay, so one of this cos goes, half I am taking outside. Okay, so this sin x by 2 and cos x by 2 is there. Okay, so if I take this cos x by 2 here, then it will be tan x by 2, right? So this will be tan x by 2, and then there is 1 upon cos square x by 2 here. 1 upon cos square x by 2 is sec square x by 2. So I can write it here. Okay, now you have to use that f dash of x fx formula. So if I substitute t as tan x by 2, then dt will be what? Sec square x by 2, derivative of tan x by 2 into half, that is derivative of x by 2, right? dx. So I can take this half if I write it here. Okay, then this whole thing will become log of tan x by 2 plus c. Okay, now we'll prove sec x dx is equal to log of tan pi by 4 plus x by 2 plus c. Okay, so this is the second integral of sec x by 2, sec of x dx. Okay, So how to start this? You can write this sec of x as cosec, correct? In terms of cosecs, what will be it is? So pi by 2 plus x dx, right? How? Pi by 2 plus x means here in the second quadrant. So cosec of pi by 2 plus x, pi by 2 is there, so transformation, so you can write it as sec of x, okay, using the trigonometry which we have learnt in 11th standard. Okay, please refer your 11th standard trigonometric identities, whatever we have learnt in 11th standard. So we have to use here now cosec of x, integral cosec of x formula which we have learned just now. What it is? Integral cosec of x dx is your log of mod tan x by 2 plus c, right? This you have to use here. So this will be log of tan of your this is x by 2, so you have to divide this by 2, half you have to take. So pi by 2 plus x divided by 2, not dx, it is plus c. So this will be 10 pi by 4 plus x by 2 plus c. Okay, so let's start with some examples. Okay, so here is one example. Okay, so if I take t as x square plus 9x plus 30, which is our denominator, then the derivative is 2x plus 9. So I can use that formula f dash of x upon f of x. So I can directly write this as log of f of x, which is our this function.